Continuing on with our study on modernist architecture, we left off in the late 1940s. We are going to pick up with, so we'll cover from about 54 until right on the cusp of 1980, which is going to put us on the doorstep of postmodern architecture. We're going to look at two late modern or early postmodern architecture projects today, but really reserve the majority of the postmodern architectural period for study in the next lecture. And we're essentially going to complete modernism today from 54 until I believe 78 or 79 is the last building we'll look at. So we're going to start here. This is the Ronchamp Chapel by Le Corbusier. I'll give the dates again, although we started with two Le Corbusier projects in the prior lecture. If you haven't already done so, a reminder now to please remember to check out that lecture before completing the exam for modernism. Le Corbusier, again, was Swiss-born, Le Chaux de France, a Swiss-born French architect who lived most of his life in France, identified more as a French architect, really identified as an international architect of French origin, lived from 1887 to 1967, perhaps one of the most celebrated, revered, and studied and even copied architects from all of history, I would say. Highly influential, both for his works as well as for his writings. Corb completes Ronchamp in 1954. It's considered a late modern project because, as you can see, if you'll remember, Villa Savoie and his 5 points, certainly the experimental nature that he was exploring within architecture, but still having some rigidity in terms of its orthogonal representation, generally post and beam construction, a lot of almost exclusively, in fact, exclusively vertical and horizontal lines in the Z direction, with some exploration of the curved line with the porte-cochere, and then also the parapet that expresses itself on the roof pavilion, with the exception of those two, use of predominantly straight lines. But certainly that exploration or that interest in the organic amoeba-shaped geometry has started there, but really reaches its crescendo for Corb with Ronchamp Chapel. Highly organic forms and shapes, still using a lot of the same materials, concrete, a little bit of wood on the inside, some metal used for the windows. So not really a material change, but a change in the geometry that he's expressing with those same materials a little bit later on in his career. As one might say, he is really discovering who he is as an architect more freely and more expressively. He wants to kind of create a tabula rasa. All the modernists, to some degree, have an endeavor to basically create something new. I covered this to large part in the prior lecture. Modernism is really the first movement that doesn't have a foundation in any prior architectural style or period, and is really trying to invent something new. Of course, there's exceptions to that, like there is everywhere. Mies Barcelona Pavilion and his kind of paying homage to classical antiquity. We haven't looked at Kahn yet. We're going to look at two Lou Kahn buildings today. Certainly, he has a sense of respect and even an express gesturing towards some classical architecture. But with few exceptions, It's really, modernism is this attempt to create something new. And Corb at Ronchamp is, I would say, doing that more than any prior project of his, where he's basically creating a clean history and giving us a new architecture that is very fresh and innovative and not based on anything prior. It's The prompt was to create kind of a meditative and reflective space. It's on the site of a there was a chapel before that I think had been destroyed, and so the the group that commissioned him to build the new chapel was in essence building a chapel where there was one before. The plan is quite interesting at Ronchamp. I'll get to the plan here in a slide or two. And one of the things I'll point out to you on on the floor plan is actually something you're seeing here in looking at the interior elevation of the main chapel. And you can kind of read probably best in these 2 or 3 windows, maybe a little bit here. The glass or the glazing is set back quite a ways away from this interior plane, which is in effect the wall. So the thickness of that wall is quite extraordinarily wide relative to the normal thickness of a 6-inch, 8-inch, 10-inch, 12-inch concrete or block wall that may have been common for this time. Corb is doing that in part for effect, but also using that to play a structural game. And in fact, this slide is a perfect slide to demonstrate this on. Within the thickened wall plane, within the thickened wall cavity, so what he's doing is he's placing the actual columns that support the roof load within the walls. So he's kind of hiding the columns inside these thickened walls, doing some interesting things with respect to the interior quality in how the light enters the space through those sort of chamfered edges that are necessary when you have such a deep wall cavity, because with the actual opening in the plane being set so far back, he, by tapering or opening up the channel or the section through, he's able to admit more light and actually give ourselves more chance for the light that is coming in to actually make its way through. Whereas if he kept that horizontal line where the window opening is clear across in section, less light would inevitably be admitted. So he's maximizing this sort of playful thing, which we're going to get to the windows in a moment. But within, that's the one kind of affect, but structurally, the more practical thing he's doing is he's burying the columns inside these thickened walls, which are supporting the cast in place concrete roof. And he's basically telling us what he's doing through the architecture without using words, really. He's giving us this little sliver of light, which is interesting in the way it's able to bring light in through ordinarily the edge that's considered an opaque edge, where a vertical plane meets a horizontal plane, especially when it's an interior wall meeting a roof that's concealing an interior space. He's bringing light in through that edge, which is not a common thing to see. But he's able to do that because the column is really what's supporting the roof, and the wall itself is really this kind of a creative way of infilling between the columns from the perpendicular wall to the perpendicular wall. Essentially a curtain wall. So some of the same ideas are still here with respect to the free plan, but here, instead of kind of showing off the notion of the free plan, because the piloti are expressed and pulled to the outside, which means the wall is now liberated, he's still kind of playing within that same innovation, but he's actually putting the wall plane back in the plane of the column and doing something different to kind of show us the game he's playing with wall and with structure. So a really interesting element there. Here you get a sense. Okay, so when we get to the plan, remember the notion of the outside chapel. which is another innovation that Corb gives us at Ronchamp. This is a view of the interior chapel pulled back a little bit to get us a slightly better sense of that wall that we were looking at kind of obliquely earlier. Okay, so the plan, there are two ways to enter Ronchamp. There's the entrance at the and there's the entrance at the north. On the interior is this large chapel. So the space, these are the pews. So that image that we were looking at, the first image or the second image of the first image of the interior we were looking at is positioned here, looking this way. So you get a much better sense of the kind of tapering of those openings and the thickness of that wall here in plan, because the poche or the black represents the solid wall plane. So this is this kind of real thick, curving wall with the tapered openings admitting light into the space, all of which create this interior chapel. But there are also these three side chapels. The four elements together with a roof plane that extends out to meet the walls that project out past the opening. So this is kind of the conditioned envelope of the building is effectively here on the inside of that line that I just traced, meaning this is all outside, but it's under roof because he's extending the roof plane to this point and to this point, creating really a fifth worship space or an outdoor chapel space by virtue of him using in a clever way the negative space created by the extension of the roof plane. 4 to 12 foot walls. So they're about 4 foot here in section in thickness, and they're up to 12 feet thick here in section. So again, inordinately thick and deep wall cavities. And then the random window pattern is something that the scholars who talk about Ronchamp point out, which I interpret as yet another kind of signing to us that the wall again doesn't have a structural role in the assembly, and as a result, I can be highly experimental with the placement of windows along this wall plane. Okay, that's Ronchamp, one of the most important buildings really in the history of architecture. We're going to go now to another architect who we have studied some of his works, an architect who came out of the Bauhaus, you'll remember. I think we also looked at the Seagram building. We're looking at the Seagram building. I think we also looked at his Barcelona pavilion, which is essentially the German pavilion for the Barcelona World's Fair. So we're looking here at Mies's largest work in America, which is the 38-story Seagram Tower, the office tower, in the middle of Manhattan, New York City, where for about 60 or 70 years up until this point, so this is built 1958. Mies, as I mentioned in the prior lecture, lived 1886 to 1969. For not the prior 60 years. By 1958, multi-story high-rise construction had probably been around for, I would say, closer to about 55, maybe. Yeah, okay, sure, 60 years. And for, I would say, the first 10 or 15 years, there was no real sophistication with the building and planning ordinances and laws that were enacted in the city of New York. But as soon as the volume of construction started to become very obvious that if left unchecked, the city of New York was going to be buildings placed up against buildings with developers using the full lot area for maximum development, for maximum capitalistic pursuits, if you will. And it would have resulted in something really not healthy and leaving no space for movement, for human occupation, for the urban condition for vehicles, cars, let alone the environmental impacts when the towers don't have space to breathe and sufficient outdoor air to circulate in through the systems. So I would say about 15 or 20, by about the 1920s. Again, I don't know the history of New York, and I'm not interested in kind of doing a deep study of that. But suffice it to say that New York City had passed pretty strict laws that dissuaded maximum development patterns and required buildings to kind of step back as they moved up to provide sufficient kind of open areas amidst this quickly expanding um, um, cluster of large, tall buildings, one after another, lined almost side to side, in often cases with zero property lines. So Mies is actually doing something a little bit defiant with respect to that. Not defiant, but out of the ordinary, where he convinces the Seagram Company, which is a company that makes, it's not whiskey, it's um, anyway, Seagram's, the alcohol, the company that makes Seagram's alcohol. This is their office tower, and what he's doing is he's actually restricting the development potential of the site by using almost only half of the available land where the tower itself sits. I think this portion to the rear is a part of Seagram Tower as well, so I believe the property extends further back. But for the purposes of the point, the sort of urban move that Mies is one of the things that Mies is remembered for at the Seagram Tower is the restraint exercised in holding the building back, and it's actually held back exactly 100 feet from the street. And really, all of this, all the way up, you can see there's nothing there other than the fountains and this entry plaza that's up about 7 or 8 steps from the actual ground plane. So the building creates this kind of plinth level that's above and removed slightly from the kind of busy, the chaotic street grid of New York. But you're not stepping off of the street grid into a building as you are in some of the adjacent buildings and so many other buildings across the city of New York. So you have this kind of intermediary zone that he's introducing that pulls you off of the street grid, but gives you an opportunity to kind of walk along, and people can even hang out here. It's not necessarily used and owned only by the building's inhabitants, the people that work in this building. It's really for anybody who happens to be in this part of the city and wants to, pull off the grid and find some respite there for a few moments. So he's holding the building back 100 feet. There's again, Mies, in a common Mies fashion, there's a classical reference. The classical reference that the book mentions that I want to point out as well is that there is a tripartite composition. Though we've talked about tripartite composition ad nauseum, base, shaft, capital, the Beaux-Arts, the kind of ground plane, the middle section, the upper section, three-part composition, which we often find and we've talked about in the expression of the elevation, or the z coordinate, if you will. What Mies gives us is a tripartite composition. If you were to look at a section through here, you have the street grid, you have the entry plaza, the open entry plaza, and then the actual building. So you have this kind of sequence of arrival into the building, which is something that Mies was very proud of, very adamant about, and ultimately was successful in convincing the Seagram Company to build less than what they could, but as much as he felt they needed to be able to have their corporate headquarters here, but also to stand out as an important work for the city and really for capitalism in general. So restraint is the kind of key point there. City entry skyscraper. The other thing that's very that Mies is remembered for at Seagram, although he repeats this at a similar thing at Crown Hall, which we're not going to be looking at, but if you're interested, look at Mies Crown Hall at IIT, the Illinois Institute of Technology. Look at his Lakeshore Drive apartments in Chicago. That's another a good example of his expression of structure. What Mies is doing here is he's actually expressing the vertical structure of the tower by placing, and actually it's deliberate and it's also fake, by placing, these are actual I-beams, they're shaped I-beams, formed I-beams out of bronze, I believe. He's cladding them on the outside of the building, and clearly they're actually not structural because they don't even attach at the ground plane. These columns certainly go down to the ground plane, and we can read them as being structural. And in fact, you can read them up through the building, through the glazing. But these things are really just expressional elements to emphasize the structural nature of the facade, but in fact are just tacked on elements that don't actually have structural properties. But what he's doing is he's expressing the verticality of the 38-story tower, or emphasizing the verticality of the 38-story tower by introducing these kind of think back to Peter Behrens at the Turbine Hall, and how he was pulling the structure out and pushing the facade or the glazing back to kind of establish a hierarchy of structure relative to glazing. Mies is doing a similar thing here, except in a less genuine way than Peter Behrens, because for Behrens, the structure itself was what was pulled out. Here, the structure is actually pulled back into the building, so it's more Corb in terms of free plan, but Mies is expressing what Behrens was expressing by emphasizing the structure, at least the grid system of the windows, by tacking on these vertical I-beams on the facade. The third thing that I want to point out, that I would love if you remember this as you kind of continue on in your architectural studies about Mies and the Seagram Tower, is how he is further breaking down the differentiation. So what Mies is doing here is he's blurring the boundary between inside and outside by literally extending the ceiling on the inside through the outside over where the exterior entry into the building is. So this is, as we're approaching to the left would be the entrance into the building. You can see very clearly the ceiling, the architectural ceiling on the inside is literally the same as the outside, and he's kind of blurring this the plane in between, or the zone in between inside and outside. You could be sitting inside, looking outside, and really seeing the same kind of palette of materials, which may make you forget for a brief moment that you're actually inside, and maybe psychologically put you in the space outside, or vice versa. You might be in the plaza looking inside, and you're seeing the same quality in there, and so you kind of bring yourself to having that same perhaps the same level of comfort as one might have on the outside, even though you are on the inside. So he's playing this game and further blurring the boundary, like lots of modernists enjoy doing with exterior and interior. Granite in the this is the top of that plaza level. This is the entry that we were actually just looking at. You kind of enter through those sidewalls there. You get a good view of those express fins on the exterior glazing, and then the spandrels are really just kind of hiding the floor system beyond. There's a real good view of that kind of transition between urban, plaza, semi-private, and then the actual Seagram Tower. There is a plan. You can see the kind of rigidity in the grid system. There's a good view of this is the plaza with the two fountains, and then this is the actual tower portion here. Okay, from Seagram, moving to another Frank Lloyd Wright building. Hard to say one of his most celebrated, because Frank Lloyd Wright had such a prolific career. And I mean, we talk about Frank Lloyd Wright as almost having three consecutive careers. I mean, he did enough work in any one of his 20 or 30-year periods that we like to kind of break up his work into, for any architect to have lived and died and done that amount of work that he did in 1/3 or one of those 3 careers, to be very proud of his or her legacy. Lloyd Wright essentially repeated that 3 times and kind of reinvented himself each time. But again, I don't want to get too deep into that. This one, he builds in 1959. In fact, he dies, I believe, before this building gets built. I'm not 100% sure about that, so someone can look that up and get. Oh no, he does. I have it right here. He lived 1867 to 1959. I think I probably said that in the prior lecture where I first introduced Wright. And this building is completed in 1959, and I'm fairly certain that he doesn't see the building completion, and it gets completed shortly after his death, although he was certainly involved in the construction of it. One interesting kind of anecdote I like to tell about the Guggenheim Museum is the color white, the white plaster that you're seeing in the museum. And by the way, the museum, the original museum, the Frank Lloyd Wright Museum, is this portion. The museum tower was added by a very, in fact, we're going to look at one of his works as well, a postmodern architecture, Charlie Gwathmey, who did this addition to the museum. But really, when we talk about the Guggenheim Museum, we're talking about Frank Lloyd Wright's original Guggenheim Museum in the foreground, 1959. So the stacked white cylinders are the clear kind of formal uniqueness of this project. They're the sort of identifier of Frank Lloyd Wright's design. It's reinforced concrete, and it's really about what he was wanting to do, and I believe successfully was able to do on the inside programmatically on how it's a museum, in how we view art that drove the form that we're seeing on the outside. So this is a project that, like many projects, that the architect started on the function and the way one moves about the building and the way the building functions on the inside, and design that out to really give us the exterior expression, not the other way not the other way around, which is that he was more concerned about the way the building looks as an object and then figured out the interior planning. So the atrium so you enter through this kind of portico, if you will, or the deep overhang. Those are the entry glass walls. And as soon as you enter through it. Basically, the glass doors that you are looking at are about here, and you enter almost immediately to the right into this large 92-foot tall atrium, which has a beautiful skylight at the top. We'll see in a slide coming up here in a second. But the atrium is the focal point around which the art gallery effectively ambulates or moves around. So that the galleries are actually the hallways, and the hallways are actually a continuous diagonal, not a diagonal, but a continuous circular pathway that's slightly inclined, such that the way we're supposed to view art in this museum is enter through this atrium, take the elevator to the top floor, and then basically circulate down from the top, winding around and viewing art to our left, with this atrium to our right, as we kind of repeat that process over 6 or 7 floors to get back down to the ground, and we're done seeing the art. So that's really what Lloyd Wright designs and kind of innovates with the Guggenheim Museum. Spiral sequence is what the book calls it. 6-story. I wasn't sure if it was 6 or 7. And it's, again, a continuous pathway going down. There's a view, and then there are these kind of pop-outs. So it's a continuous pathway, but you have an opportunity at every floor to kind of pull off that pathway and just kind of look down, people watch, look up, catch your breath, make a phone call, whatever, whatever one might need to do while they're enjoying a day off at the museum from taking a break from kind of looking at artwork, just kind of a third space is how we like to describe those kinds of things. There's actually a plan view of that balcony that's off of the hallways. What else do I want to say? So there it is in section. Let's see. This is the elevator shaft here. And then this is the entry sequence. So that's the reception desk. This is the entry into the building. You're almost immediately in this large atrium space. And then the extension or the addition that you saw is effectively back here. And I believe the connection happens here into the newer museum. I think it was completed in the 90s. Okay, moving to another highly celebrated, one of my favorite modernist architects, Eero Saarinen, Finnish architect who lived from 1910 to 1961. Died way too young, unfortunately, at 51 years old. I don't know what the cause was. It was some, I don't know whether it was preventative or not, whether it was preventable or not, but Eero really dies, I would say, at the peak of his creative production period. I mean, he was like just hitting his stride, had done a series of just absolutely amazing buildings, one of which is the Dulles International Air Terminal, the TWA terminal at Kennedy in New York is a phenomenal work if you're interested in Saarinen's work. The St. Louis Arch is another work of architect, a competition that he had won that he's very famous for, that no doubt most, if not all of you have seen. Just phenomenal body of work that Saarinen was creating. The Dulles International Airport being no exception. Completed in 1962. Again, he died in 61, so he didn't see the completion of this, but was very involved in the design, obviously, and then even was observing the construction. And they were solving lots of problems during construction. One of the innovations of this project, okay, so this is an airport terminal, and the Washington, D.C. Airport Trust Authority wanted flight to be expressed in the architecture of this design solution. So Saarinen is very clearly expressing like a bird or wings in flight with the section of this building. And you're looking at basically this one of the side, what I would refer to as, I guess, the gable ends of the building. The front is to your left, really the back where the air tower is and the airplanes would be, are to your right. So the public approaches from the left and then makes their way to their airplane in the right of that slide. This is looking from the opposite end. So this is the sort of drop-off traffic aisles. It kind of, cantilevers, or it has the catenary curve opens up to be taller on the public side and smaller on the private side, I think, which is also suggestive of how the building functions. That's the point that I wanted to make, is that he has this sort of beautiful, kind of poetic curved catenary line that really defines the roof plane and really defines the building. It's, I would say, one of the most prominent geometric elements in the assemblage, the architectural assemblage. But that curve is actually continuing up to create more volume on the front side than the back side, and I think that's a deliberate move by Saarinen to really address the public on this side and suggest that that's the sort of non-public side of the space. That's one. The other is the concrete, the cast in place columns that really support on this end and on this end the two kind of points of the catenary curve, which is basically built by running 1-inch diameter wire and letting it really hang letting gravity do its job with the 1-inch reinforcement. There's a ton of reinforcement in this building, both in the roof plane as well as in the columns, because nobody had ever done anything like this before. That's why Saarinen is so celebrated, because he's innovating. He's doing something new in architecture, like pretty much every architect that we've studied this semester. That's certainly a repeating theme, is that architects like to create new things. That's part of what how architecture defines itself, is the pursuit of innovation, of creativity, of newness. Structural engineers who haven't done 50 of these in the past, and I think this is Ove Arup, which is still a prominent structural engineer that practices today. They throw, literally tons of rebar in each of these columns. I want to say each of these columns, in fact, I think I have a picture of it in construction. There's a real good picture of it in construction. So concrete does real well in compression, but is quite poor in tension. And so rebar is basically what's making up for that one flaw in character that concrete has, which is that it can support a ton of weight, but it doesn't do well when you pull it apart. Well, the rebar is basically counteracting that negative attribute of concrete. And so together they're making this very strong, stable structural element. But like I said, each one of these columns, I believe, has about 16 tons of rebar, reinforcement bar, to actually obtain its structural integrity, and also to counteract the force of the catenary roof that's coming in. So you can see actually the start of the next bay here, but one bay is already completed here. So that's the roof, the concrete roof having been completed in one section and being started in the next section. I think I have a better picture of it. Here we go. There's a good picture of it. So this is 1-inch diameter rebar. Let me make sure I get my facts straight here on the structure. Yeah, 1-inch diameter, 1-inch diameter cable, and then precast concrete panels that are cast in a plant and delivered to the site to basically make up that smooth expression of the roof plane. There's another view of it. Again, the bird's wings, or the sort of act of flight, I think is very. I think Saarinen expresses that beautifully at the Dulles Airport. There's a nice elevation view of the front side. So it's repetitive. It's not dynamic in the sense that it's not Morris Hunt's New York City Met Museum, where it's kind of flanked on the wings. There's the center section. The center section is divided into 3 parts. The 3 parts are built. It's basically very horizontal and repetitive. But as a result, he's able to achieve a high level of transparency. And then actually the rhythmic quality of the structure becomes, I think, one of its redeeming qualities, one of the qualities that make it the beautiful architecture that it's celebrated to be. Okay, moving back to Europe. This is so we're kind of going in sequence chronologically, if you haven't figured that yet. But we were in 59. We're now in 1963. This is the Berlin Philharmonic Hall, and this is German architect Hans Scharoun. Hans Scharoun lived 1893 to 1972. Both of these buildings together comprise the project, which is the Berlin Philharmonic. What the Berlin Philharmonic is unique and celebrated for is actually, it's a really good kind of a predecessor case study to look at when looking at the last project that we're going to see today, which is Jorn Utzon's Syndey Opera House. What Scharoun is doing is he's basically building a modern version of the arena form theater, really for the first time in modern history. And if you're not familiar with theater design, there's essentially 3 prominent ways of arranging a theater presentation space. There's theater configuration, where you're sitting, stage is on one side. You have seats facing the stage, and you may have seats kind of diagonally or even kind of perpendicularly facing the stage. There's thrust, which is very similar to that, but the stage is actually pulled into the audience seating area where the perpendicular seats are almost looking sideways or 90 degrees at the stage, and then you have the front seating that's looking straight ahead, and then you have the opposite of one side on the other. So basically, the stage is pulled into the audience seating area in thrust, and then you have arena, which basically puts audience on all four sides. So in the Berlin Philharmonic, which I think, yeah, there's a plan of it. So it's primarily, I would say, primarily thrust, but it is categorically arena configuration because there's seating on the backside here. So you basically have 360-degree view of the Philharmonic or the performance on stage. I think it's a fascinating plan. I love Sharoon's complex solution at the Berlin Philharmonic, and I certainly can't leave out the most important pursuit that Sharoon was after, and I believe was successful in carrying out, which is it's a finely tuned acoustic space. So the form, you can see the form of the ceiling, the form of the roof here is based on in-depth study, repetitive series of studies to try and optimize the way sound bounces and reverberates off of ceilings and walls to create what was believed at that time to be the most perfect acoustic space for the performers of the Berlin Philharmonic to occupy and to perform in. So this sort of very German kind of endeavor to achieve this sort of level of precision and perfection in their work, as complex as it may seem or be. And then there's even, I don't know if Sharoon himself wrote about this or if architectural historians or theoreticians have written about it, but the fact that it takes place in this kind of, New York City Central Park-like atmosphere with this large green park space. I don't know Berlin well, so I don't know the name of this park, but I know the Philharmonie Hall is directly adjacent to it. There's also, I've read about some references being made to the kind of form of the building and the tree canopies that define the sort of space adjacent to it. Whether there's any truth to that or not, I don't know, but I have read that from at least one source in the past. Okay, so that's the Berlin Philharmonic. All right, we're looking at Bob Venturi's work here, and this is Venturi's mother. So Bob Venturi is another prominent architect. This is one of the postmodern pieces that we're going to look at in today's lecture, but it's early. It's happening kind of at the late period of modern architecture. So this is yet again Bob Venturi, an architect trying to create something new in a period where he's seeing nothing but modernism around him, and he's saying, damn it, I want to make something different. I want to make something new. I want to kind of reject some of those ideals or the dogma of modernism. Well, to a large degree, there are a lot of modernist characteristics in a lot of Venturi's work, but this is kind of his attempt to enter into a new territory, which again isn't known as postmodernism. Obviously, at the time in '64 that he's doing this, his endeavor is do something unique, do something new, and then we as architectural students who come around 30, 40, 50, 60 years later look back at this stuff and start to say, okay, that's when the kind of bifurcation was starting to happen from modernism. But let's look at what Bob Venturi was doing here for his mother at her house, which is properly called the Vanna Venturi House. This is in Philadelphia, Pennsylvania, 1964. Bob Venturi lived 1925 to 2018. Okay, so the couple obvious things that you're probably seeing here is the split pediment, and perhaps that will take you back to Leon Bautista Alberti, who was doing all kinds of interesting and experimental things with how to put a facade on a pagan temple or a basilica or a Gothic cathedral and make it new. And some of the devices he was using was the split pediment, the broken pediment, so on and so forth. So Venturi is almost kind of going all the way back to that here with the split pediment. The split pediment inevitably also establishes some symmetrical ideas, because it creates a point which is, in this composition and most compositions, at the center of the facade, and by doing so, it establishes symmetry. So on either side of that point, we can see that there's kind of equal surface area. So there's symmetry, but there's also this is the kind of sort of tongue-in-cheek nature that postmodernism tends to have. So it's symmetrical, but it's actually asymmetrical. So there's a little bit of a, kind of a tongue wagging, if you will, um, in creating the symmetry. He's given us the ribbon window on one side and actually a large window and a small window on the opposite side. So yes, symmetry, but also asymmetry at the same time, kind of playing this game with us. On the inside, there's kind of, again, this sort of tension that he's created. The thing that's commonly referred to, and I think I have an interior photo of it here coming up, is once you enter the house, there's the fireplace, which is commonly considered to be the hearth or the center of at least the home, the domicile. Well, the hearth, being the center of the house, here in this composition also has a stair wrapping around it. So, and the stair has kind of a prominent role when you look at the kind of quality of that interior space after you walk in. And so the two of them are kind of fighting with each other and fighting for really control of the center of the fireplace. Is it the fireplace that's the most prominent thing at the center, or is it the staircase that's the most prominent thing at the center? Kind of left to us to decide. Oh, darn, I don't have an interior photo of it. Let me see if I can bring one up here. His seminal book, Complexity and Contradiction, which he writes just a couple years after completing this house. There's a good view of the staircase. So there's the hearth, which is clearly, a prominent element in the living room space. But then with the light that's coming in through here and the sort of somewhat sculptural quality of it, the open nature of it, the fact that you can kind of clearly see the stair. There's no railing interfering with your view. He's not even bringing down a soffit down. That's the underside of the floor above, basically. So giving it a kind of a prominent role where ordinarily the hearth has that prominent role. The two are kind of, competing for control, if you will, of center. There's another view of it. Looks like that might have been one of Venturi's original sketches. And then Venturi and Denise Scott Brown together. So Denise, his longtime collaborator and wife, I'm pretty sure. She was basically the first female to be awarded the AIA gold medal because the two of them received it together. I don't remember what year, but that was definitely a proud moment for the two and for her as really the first female recipient of that award. Okay, Sharoon we covered. Venturi we've now covered. Fireplace, stair, scale, refinement, symmetry, asymmetry, complex. So Complexity and Contradiction was written in 1960. The house was completed in 64. Okay, from Bob Venturi, we move to another one of the greats, like Corb, probably one of the most highly regarded modernist architects, if not one of the most well liked and celebrated architects in all of history is Louis Kahn, Louiskahn, Louis Kahn. Lou Isidore Kahn, I believe was his middle name. Lived 1901 to 1974. Does more amazing work than I could even cover if I lectured on just his work for an hour and a half. And we're going to see another one of his projects in this lecture. But the first one we're looking at is this one here in 1965, completed in San Diego or La Jolla, California. And this is the Salk Institute. And the client is Jonas Salk, who had prior to developed the polio vaccine. So was already a prominent scientist or biologist or whatever his actual vocation was. Certainly an innovator, obviously, for creating the vaccine and being able to get it to market. He hires Kahn to build a biological research center here in La Jolla, California. And the prompt in creating the building is for the architect, or for Kahn in this case, to, quote, create a facility worthy of a visit from Picasso, end quote. So clearly the objective to create something special architecturally is there from the beginning, which is a huge, huge leg up for an architect. When the client is coming in with that objective of doing something special, we as architects, practicing architects, are always trying to do something special in our work, given the parameters and given the budgets and the time constraints. I mean, we don't want to be negligent in pursuit of creativity, of originality, but we are starting all our work with the objective of doing something original, and Kahn is no exception. So Kahn here is being told, do that from the outset, do something special and unique here. And so he sets about to create this amazing space. Actually, in design. What ends up getting built are only the labs, but he actually designs the labs, the conference center, as well as the place for the scientists to live or to stay overnight. So there's really three parts to the design, of which only the research laboratories get built. But nonetheless, the laboratories that get built are, as you can even see from this exterior view, very open, very spacious. Kahn, we consider to be the master of light. The way he used light was just second to none. I mean, just brilliant, brilliant. Yes, used a lot of concrete. Yes, used a lot of kind of brutalist architectural elements. But when you handle that so delicately with how you bring light into those spaces, the cold, otherwise brutal nature that those materials tend to take on actually kind of flips that on its head. And by bringing light into these spaces and bringing that sort of warmth, that natural quality, has a tendency to kind of open up the volumes and actually give the otherwise cold elements of metal and concrete a very warm feel, in fact. Whereas when there isn't as much availability and harvesting of light, that's when we tend to feel kind of the cold quality of those materials. So this is a plan view of the laboratories. One of the things Kahn does brilliantly here is he introduces this idea of putting labs, then infrastructure all together on one level, and then labs again on top. And the reason he does that, Kahn has this thing that he has started about 7 or 8 years even before this project, where he defines a building as being made up of served and service spaces. So the service spaces are really the purpose of the building. They're the main functions that take place in a building. And then there's the spaces that serve those service spaces. So there's the primary spaces and the places that basically are acting in the service of those spaces. So think of like a hallway, a bathroom, a closet, a kitchen. These are things that are not necessarily the reason for the building. In this case, for the Salk Institute, it's the research labs themselves are the reason for the building. And then there's the spaces that basically that serve those spaces. So those would be the served, and then there's the spaces that serve those served spaces. And so he actually does this in elevation or in section by putting the infrastructure together all on one level, so that the janitors and the people kind of maintaining the building don't actually have to bother the researchers, which is something you would commonly find in a college environment. And Kahn did a lot of work in higher education, did lots of buildings at Yale, at several other campuses across the United States, actually across the world. And so he was always kind of dealing with this problem of sort of service and served. And so by putting the infrastructure all together on one floor, he realized he can kind of innovate and create a situation where the lab researchers can do their work uninterrupted on one level, and infrastructure can all be kind of maintained and taken care of on another level without those two necessarily interfering with one another. Puzzle and concrete is the concrete that you're looking at, which is why it has that kind of light white quality to it. And then the use of teak wood, which is a unique kind of a signature of Kahn. There's almost always something wood, some level of wooden detailing. Oftentimes it happens where you come into contact with the building. That's actually something from Alvar Aalto, another highly influential, phenomenal architect in his own right, who kind of had a maxim that, like, where we touch, he would use a lot of concrete, use a lot of steel, industrial materials, but he would almost insist on, like, the handle and on the entry doors into the building, or the handrails of the stairway, to always be wood, because he believed that where the human being touches the building or comes in first contact with the building should be a warm material and should not be a cold material. In a similar way, Kahn always kind of punctuates or accents his concrete or steel, most often concrete work, with wooden detailing, like you see here, with the teak at the openings, at the window openings. Okay, that's Salk. Moving to New York now, from West Coast back to East Coast. This is the Met Museum, the Metropolitan Museum. I'm sorry, the Whitney Museum, not the Metropolitan. Metropolitan Museum was the Richard Morris Hunt Beaux-Arts building that we looked at 2 weeks ago, or a few lectures ago. This is the Whitney Museum in New York. This is Marcel Breuer. Marcel Breuer is a German architect who settles in the United States, also hailed from the Bauhaus, lived 1902 to 1981. Obviously, lots of concrete being used here. Brutalist. I mean, it's hard to deny the kind of brutalistic quality in terms of its material, but also in terms of its form. Very kind of heavy, simplistic, cubic volumes, with the one kind of exception to the simplicity being the sort of stacking, or the slight cantilever of the lower level to the second lowest level to the third level to the fourth level, thereby giving the building this kind of interesting quality of a three-tiered portico. But other than that, a very kind of a pure rectangular form. Really down here, which let me see if I have a section of, is one of these. So that we call this the Breuer window. It's like the only time where he's letting himself go, if you will. There's obviously heavy restraint and discipline and order in kind of keeping things so simple here. But the window is where he gets expressive, and actually kind of plays with the vantage point. Oftentimes when you're not oftentimes, 99.9% of the time when you're standing at a window, it's in a wall and the glass is in the same plane as the opaque surface next to you. Breuer has kind of given us something new and interesting and innovative, if you will, in that we're standing in a plane and we have opaque on either side. And we're looking actually through glass diagonally in relation to the opaque plane on either side, giving it a very kind of an interesting quality. And I take that back. It's not glass on both sides. It's really just on one side, and it's fully opaque on the other side. But what the other kind of character defining element of Breuer's Whitney Museum. Okay, here we go. I don't have a section drawing. It doesn't look like, but there's a picture showing you really what happens at the street level on either side of the entry into the museum. So you kind of come in off of the sidewalk here, you go through this um, um, like moat, almost moat-like bridge that's kind of open on both sides. And then you see this lower volume down below, which is really doing a couple of things. It's, first of all, bringing natural light into some of the lower spaces where if this was a solid floor plane here and an extension of the sidewalk, yes, you would have basement space, but you would have basement space that would not have a really pleasant quality because there wouldn't be really any natural light entering that space. Well, by carving away and creating this kind of semi-outdoor garden, he's able to get some light to ordinarily the lower spaces where ordinarily you wouldn't usually have the benefit of having natural light, giving this kind of lower space a very interesting quality. And I think, if I'm not mistaken, that's actually a restaurant or a cafe or a dining area of some sort. But also he's able to activate this space to be an outdoor space, but an outdoor space that now clearly belongs to the Whitney Museum. If you think back to Mies and the Seagram Tower, there's a similar thing happening, but because there's no kind of vertical separation, there's no protection. You can't claim this space really as belonging to the building, nor can somebody from the city claim that space as belonging to them. It's really this zone that is in this gray area, and we don't know who it belongs to, and it's really for open use by either side. Whereas at the Whitney, he's creating this pleasant open space, which has the qualities that you might want to enjoy if you were out on a public plaza, but actually being in a semi-private space and somewhat protected from the street. This also triples as a sculpture garden, so that you don't necessarily actually have to enter, pay for a ticket, and spend 3 or 4 hours at the Whitney Museum to take in the art. You could just be walking by on your lunch break, stop for a few seconds on against this railing, look down into this plaza, and observe some of the sculpture that gets curated in that space. So it's actually even taking some of the interior function of the museum and putting it on the outside and making it. There is actually a really good view of it from the lower plaza level up to the street level. So there's a section of it. This is that kind of interesting quality that I would say is a unique thing. We don't always experience a window that way. It's a bay window, which I suppose we experience somewhat commonly in residential spaces, but not very common in a public setting like a museum. And then also the bay window tends to be kind of above a counter, whereas here he's actually brought that tapered sill all the way down to very close to, looks like, the ground plane. It happens again there on the opposite side. Okay, so that's Breuer at the Whitney. Okay, this is the second, I think second and only, this is the second postmodern example of postmodern architecture, which again, like the Vanna Venturi house, isn't, when the architect is doing this work, the architect is, I don't believe, is thinking, I'm going to create postmodern architecture. Rather, I think the architect is trying to do something unique given his or her worldview, his or her skill sets, and his or her kind of ideas that are unique to him or her. And we, looking at the work later on, are the ones who kind of index it and say, okay, this is something different than modernism. There are some characteristic elements from modernism, but it's something new, and it's really the beginning of postmodern architecture. Nonetheless, the architect, Charlie Gwathmey, is trained as a modernist, is trained by modernists, and so has that kind of foundation in his design training, but is certainly creating something unique from that training. This is what's commonly referred to as the Gwathmey residence, and I think he does this for his mother and father. And I don't know for sure. One of them, I think, is a photographer, and I think the other one's an artist. So they're kind of predisposed to be more receptive or even encouraging for the young architect to do something innovative and interesting. So he certainly has I would say he's in the fortunate position of having parents who have the ability to pay for a private personal residence to be built and developed in Amagansett, which I think might be Connecticut, but also the being in that position are also, at least one of them, I think, has kind of an art background or a creative background, and I would say is even more predisposed to encourage innovation and sort of new things to be experimented with through architecture. What Gauthamy describes he does here is the word in German is Raumplan, and what it means is basically it came out of the Bauhaus, and it's the idea of designing a project three-dimensionally, um, uh, designing it three-dimensionally and not actually drawing a plan to create the design. So it's basically the process of designing a building three-dimensionally by arranging spaces rather than looking at a flat two-dimensional plan, and then once graduating that two-dimensional plan, then moving into section and elevation and developing the work. Rather, it's kind of doing all of those at the same time, or really designing three-dimensionally. The one point I want to add here is, yes, that there's a unique term for it, but actually the Bauhaus as a school did tons of experimental research projects, and one of the many was that they discovered that the human being as a child thinks actually in three dimensions. As a young child, like a baby, thinks in three dimensions. And it's actually only through the ways in which we teach that we actually teach the child to stop thinking in three dimensions and thinking in flat two dimensions, whether it's the fact that we write on paper or that we sketch in silhouette or we sketch things in plan or section. We sort of untrain the mind that's naturally seeing the world and experiencing the world and thinking in three dimensions to start thinking in two dimensions. And then those, I guess, few of us who are interested in or are lucky enough to pursue architecture as an education are really starting to train our minds back into thinking three-dimensionally, which is really just going back 25 years to when we were young infants and seeing the world that way anyway. Gauthamy writes a lot about how his design process is that from the beginning, which is Raumplan, which is basically, instead of drawing in plan or designing in plan, he's designing by arranging volumes together three-dimensionally. The building is a wood frame building, wood frame house. It's really the only material on this project, other than, I would say, the standing seam metal roof, is the cedar siding that basically defines both the exterior and you'll see here shortly, even the interior. So he clads basically the entire house in this beautiful, brilliant vertical cedar siding. And then we see, the curved stairway has certainly a real unique quality. That's, I would say, the other character defining feature of postmodern architecture is the use of just pure, simple, clean, three-dimensional forms. The cylinder, the pyramid, the sphere, the rectangle, the cube. Three-dimensional rectangle, the cube. So these kind of, you can almost read those primitive three-dimensional objects in postmodern architecture. Here, you can read very clearly the cylinder. Going back to this original image, it's the cube with the cylinder set, and then even a pyramid kind of projecting up through it. Very, very clean volumes. There's an isometric drawing of the basically the looking down on the building it's an axonometric drawing with the roof planes removed so that you can actually see inside the building. There's the curved interior stairway. There's the rotunda that we were looking at from the outside. That's really the stairway that gets you up to this primary level, which is in effect an exterior stairway. Beautiful. I think just, really amazing quality, simple and elegant, with very little, not a lot of playing with materials. It's the cedar siding, which I suppose this might be the one exception where he turns the siding horizontally here, but vertically almost everywhere else that I've seen. And the flooring material. He even uses the siding as the ceiling material. So it's not overwhelming in terms of its material quality either. Okay, the second Lucom project might be my project. Is my favorite Lucom of light, of natural light. Of how he uses, manipulates, and actually makes the most noticed quality of his work, to the point where it almost diminishes sometimes the actual materials that he's used. The light becomes the sort of object of interest in the interior quality. What he does at Kimball Art, let me go to a plan first, actually. At the Kimball Art Gallery, it's this series of, so it's basically 100, 100, 100. It's I guess you could say it's tripartite. As I mentioned earlier, Kahn was not shy about making references in his work to classical antiquity. And so the kind of tripartite arrangement of these kind of, again, very clean rectangle, square, rectangle. But each of these are basically these rotunda, or these domes. Sorry, I'm going the wrong way here. So this wing that you're looking at is actually the volume on the right hand side in the diagram, and imagine that each of those kind of horizontal lines that I'll show you on this slide are these bands where you have this arched dome that basically is an extruded profile of a classical architectural form. And pay close attention to what happens at the top of the dome, or the top of the arch, because that's where we're going to focus a little bit on the inside. But what you're seeing there in plan is, we were looking earlier at an image looking from here at that, what would be the south facade. This is north, east, southwest. This is intended to be the main entrance. It's probably, much to Kahn's chagrin, this is at the lower level, which is really the ground level on this side. This is also the ground level, or the courtyard level on this side, but the street comes in at this level. And this is more commonly used as the entrance to get into the building. But understand this upper section to be at a lower plane than this portion, which is really the upper section. But imagine, barrels kind of continuing on through these lines in these three volumes. Now, it's a museum, and museums would love to have natural light, but oftentimes mandate that there is no natural light for the express purpose, or the practical reason being that natural light, or the ultraviolet light of the sun, when directly cast upon the artwork, can actually damage the artwork, and actually damage it very quickly. So although light would be a welcomed quality in any museum, because I don't believe, and most architects don't believe, and most museum curators don't believe, that artificial light can replicate the quality of natural light. But because natural light tends to ruin the artwork, we end up having to do our best with artificial lighting. Well, Kahn invents something really unique at the Kimball Art Museum, in that that little kind of oculus that you saw in the image when we were looking at the outside is in section a sliver, or a slot that runs through the dome at the very top, is opened wide enough to where natural light can actually come down in through the top of the barrel, or the barrel vault. And then he has these perforated aluminum screens that actually are diffusing that natural light and actually reflecting it back on this curved underside of the barrel vault, which is then basically washing the interior space with a diffuse light quality, which just people describe as having a absolutely sublime quality. There is some natural artificial light in this image you can kind of see from these spotlights, but very little artificial light in comparison to what you might find in in one of our in our local museum, or if you've spent time in any museums in Los Angeles, San Francisco. It's I don't know that there's a space that has the Skirball Museum has a really good light, natural light quality in some of the galleries in Los Angeles. But besides that one, and I certainly haven't been to every museum in California, but the ones I have been in, I don't know, other than the Skirball, there's anything that. And actually, I think there's a reference at the Skirball Museum to the Kimball Art Museum, because I think there's actually a dome that kind of mimics this quality. I don't know that for fact. I've just kind of observed that, and immediately when I saw that gallery space, I thought this looks like an architect paying homage to Lucan. So somebody who, if you know or you want to look that up. Be my guest and let me know what you find, and if in fact the architect of the Skirball Museum in Los Angeles was making reference to the Kimball Art Museum. But the point there is that it's not common for there to be such an amazing sublime light quality, in natural light quality in a museum, and you can kind of see the work at work, no pun intended, because I can count 1, 2, 3, 4, 5, 6, 7 on this side, maybe 7 on that side. Spotlights, look like 6-inch kind of round spotlights, are really the only artificial light that is in this space. And we're looking at maybe a 40-foot section of gallery. It's the natural light that's doing all the work. Use of stone, so travertine on the wall. I think this is interesting about the Kimball Art Gallery too. Wood floor, which is not uncommon for a museum, but travertine wall. So I think there's kind of a little bit of a role reversal there. It's, I would say more common for us to be walking on a travertine floor and actually seeing kind of wood paneling or wood on the vertical plane, whereas Kahn has kind of inverted that. It's travertine on the vertical plane, wood on the floor. I suppose there's actually some interesting consistency there, whether this is forethought or not. I haven't read anything about this, that Kahn has said this. Again, so if any of you are doing more research beyond what these lectures are asking you to do, please share anything that you learn or discover about some of the things that we're talking about or pointing out here. But it actually kind of makes sense from the standpoint of the stone meeting the concrete in the vertical plane, and then that kind of softening up to the wood as it wraps onto the floor plane. Okay, the last project, which is getting us up to 1973, is this building, which undoubtedly is recognizable to all of you. Which is the Sydney Opera House. The Sydney Opera House is really the first of 2 buildings that we consider to be part of. I think I've talked about in a prior lecture the notion of the Bilbao effect. When the Bilbao City Council hires Frank Lloyd Wright Frank Gehry, to design the Bilbao Museum, they come to him and they literally say, we want you to use this building and we want your architecture to help put Bilbao on the world map. And he succeeds. Gehry succeeds in doing so because it creates a phenomenal piece of work for the Bilbao Museum in Spain. And we talk about that starting the Bilbao effect, which is the notion of a public entity or a private entity who is attempting to bring regional, if not international, attention to their city or to their organization, almost appropriating or using architecture for that express purpose, giving them a needed building, solving functional problems, giving them a quality, sustainable, oftentimes long-lasting space that will serve that organization or that governmental entity for a long period of time, but at the same time also putting the city on the map. So we call that the Bilbao effect, largely because, almost exclusively because of what Gehry was able to do as an architect for the city of Bilbao and really the country of Spain, by envisioning and executing the Bilbao Museum. The first project to actually do that, again, expressly do that, was not the Bilbao Museum. It was actually 34, and let's see, Bilbao was in the early 90s. The Sydney Opera House starts in 1956 as a design competition. So it happens over 40 years before Gehry is starting his design work for the Bilbao Museum. And the Sydney Authority selects Utzon's design from the competition entrance, for which all architects were given the same prompt, which was to basically give them the opera space, the concert hall space, but also to, quote, put Sydney on the world map. And undoubtedly, Jorn Utzon does that with this magnificent work for the Sydney Opera House. But it doesn't come without its fair share of difficulty, of challenges, of failure, and of drama. So Utzon wins the competition in 56. They actually start construction in 1959. And one of the things we're going to get into here in a moment is the thin shell, sail-like organic forms and how they were able to technically solve the problem of building these highly complicated forms at that time. So think back to Saarinen, right? This is 56, 59. It's starting construction. The Dulles Museum is being built in 1962. So this is, 4 to 6 years before that as a competition, but almost like the same time as that. So what I didn't get into with the Dulles Museum was one of the ways that Saarinen and his team, one of the design solutions they had to solve is how to actually construct those forms. And they figured out the system of basically working in lifts for concrete, because in concrete we tend to work in whatever the increment might be, 6 foot, 8 foot, 10 foot. We tend to work in lifts, which will pour, let it settle, let it set, let it kind of get to its relative strength before we pour the next section, and then the next section, the next section. So what that requires is basically scaffolding to either be erected all the way up with the workers working at the first level first, pouring, setting, then pouring at the next level, or actually building the scaffolding up as you go. Well, at the Dulles terminal, remember the kind of section profile of the columns is diagonal. So they basically had to build forms in sequence or in section, moving up as they were doing the lifts. And they basically had to design that scaffolding system as part of solving the problem to actually help their building get executed. So there was a kind of interesting collaboration there that was required between the architect and the builder in that case, but also the architect thinking about constructability problems even before we get to construction, because ultimately, if you can't figure out how to build a building, it could be the most creative solution in the world, it ain't going to get built. So that's kind of what one of the first challenges that Utzon has to overcome in figuring out how this thin shell would be built. So they actually start construction on the foundations in 59, not yet knowing how they're going to execute this. And so they're spending a number of years in the beginning kind of experimenting with the engineers on how to build this thin-shelled system. I should add that Utzon's idea with the kind of organic white forms is that they represent sails in juxtaposition to the Sydney Harbor, giving it this kind of look of ships sailing in the night or ships sailing in the sea, if you will. And then, the tile cladding on the thin-shelled concrete gives the building this kind of unique, radiant quality. You can kind of see it here, this sort of dynamic, almost like a sheen-like quality which would change as the sun is moving. The quality of light bouncing off the tile exterior cladding gives the building, I would say, a unique quality that changes from hour to hour as the sun is moving about the building, and then yet again changes drastically, I would say, when exterior lighting is cast upon it in the evening. Yeah, I would say even different from the daytime quality. Okay, so 59, they're working out the construction. It's not until 1967 that they actually complete the construction on the figure out how to do the concrete precast, the shell construction. The cast in place concrete shell construction at the Opera House doesn't get resolved through research, design, iteration until 1967. So imagine they started construction 8 years prior, and it's not until 8 years later that they're actually able to close off the building and solve the roof problem. So it speaks to the kind of the sort of um, creative endeavor that Utzon started himself and the team on for this project, but also speaks to the sort of the challenges and the difficulties oftentimes that come with having these wonderful ideas or these grand objectives, endeavors architecturally. They're not easy to solve and to overcome. Certainly Utzon had a challenging time, which I think culminated in shortly after the roof construction, I believe, is complete. He basically quit the project because certainly he probably was very frustrated with the process. The Sydney government was giving him a hard time, and not without good reason. The project ended up, so it was a $7 million budget when the project was awarded in shortly after the 1956 competition. By the time the project was completed, it cost about $102 million. So imagine what is that, about 14 times the stated budget of the project is what it actually costs to build the Syndey Concert Hall. So not an easy project to execute. Sadly, Utzon actually doesn't even get to see the Syndey Opera House. So when he quits the project, I think he quits amidst even maybe some skepticism that the building would even get complete. Perhaps it wasn't even being completed to the same degree or the integrity of his design. Although I believe the integrity of his design was mainly kept intact. I don't know kind of the inner workings as to the motivation behind him quitting the project, but I do know that he does quit the project, and he doesn't quit really on good terms. And so imagine, all that hard work and all that sort of pain and suffering, and then actually leaving a project and maybe even not thinking that things were going to go very well with it, not ever getting to see the building, but then the building actually becoming, a world landmark, not just an Australian landmark, but probably one of the most recognizable works of architecture, if not only in the last 100 years, perhaps in all of history. I mean, it's a very, very recognizable, iconic work of architecture. Appreciate the work of some of these amazing architects, even though sometimes they were not able to be appreciated or appreciate their work even in their own lifetimes. So the white sails, the shell, the precast concrete, the spherical sections we talked about, and the tile on the facade. Over 2,194 precast concrete sections to actually create these highly organic, compound curved sail-like roof forms. The inside of the Syndey Opera House has a similar quality to Sharon's Berlin Philharmonic. And I guess I should say is, entry, grand kind of a lobby, processional here, and that really splits off into the concert hall and the opera hall. I'm not sure which of the two. I suppose we're looking at the concert hall here. Again, we talked at length about the exterior form here and the construction of the exterior, the construction of the roof. What we didn't talk about is the equally laborious and sort of research-based approach to that Utzon and his team took for the interior acoustic quality of the concert hall. Really, that we talked about Sharoon underwent for designing the Berlin Philharmonic is this interest in kind of fine tuning spaces like this so that they, so that the building for its main purpose that it's being built can be known for something not just of its architectural quality on the outside, but even its architectural quality, which more directly supports the function of the building or the raison d'être, the reason for being of the building, which is really the concert performance that the architecture is enveloping. Okay, that's all I've got. So that gets us to the mid 70s. We're done with modernism, and we will pick up. So you have an exam to complete over the next 2 or 3 days. Please do that. I will try and grade those by the middle of the week. And we will have 2 more lectures, one on postmodernism and then one on contemporary work. And that will round out the lectures for the semester. And then I will probably offer to schedule a few live review sessions with you all so that we can all together prepare for the final exam. Thank you.